in school. But rarely do we consider real-life situations where we can apply them. Believe it or not, permutations and combinations can have significant applications in our day-to-day life. Permutations involve arranging a set of objects and determining the number of ways they can be arranged. Combinations, on the other hand, involve selecting a number of objects from a larger set. An easy way to remember this is that permutations deals with placement. An example of this is the artist who gets first, second, and third in a drawing contest. Meanwhile, combinations deals with choice. For example, choosing 4 players from a team of 6 to compete nationally. Knowing the number of ways in which things can be done can help us make more informed decisions. Let's try to explain this with a simple example.
The sum rule.
Bob just downloaded a new food delivery app called Snatch. He's hungry and he plans to order either Japanese food or Chinese food. In the list of restaurants near him, he knows that there are 3 Japanese restaurants and 4 Chinese ones. So, how many ways can Bob pick a place to order from? There are 7 ways for Bob to choose a restaurant here. We calculate this by using the sum rule, where n is the number of ways to choose a Japanese restaurant and m is the number of ways to choose a Chinese one. Since both these actions are not done at the same time and are mutually exclusive, the expression is n plus m, and the equation is as follows: 3 plus 4 equals to 7.
The multiplication rule.
After deciding on the Japanese restaurant Hanashi Cafe, Bob looks through their menu on the app. He sees that they have a promotion for set lunches consisting of 1 main dish and a free drink of choice. For this promotion, the restaurant offers these 5 different meals and these 2 types of drinks. Therefore, Bob needs to choose a main dish and a drink to go with it. How many possible combinations can he make? Bob has 10 ways to choose a main dish and drink. As you can see from this tree map, these are all the possible combinations.
Permutation with repetition.
With his decision made, Bob tries to place his order on the app. However, before letting him do so, Snatch tells him that he has to first create a 6-digit password in order to protect his account. Now, the app also tells him that this PIN number may only contain numbers. Therefore, this brings up the question, how many potential 6-digit PIN numbers could Bob come up with here? Although it may not seem like it, there are actually a million different PIN numbers for Bob to choose from here. Now, for this problem, we use permutation. The first hint that we need to use permutation and not combination for this problem is that in a PIN number, if you so much as change the sequence of 2 numbers or swap them, the PIN number will no longer be correct. Therefore, we need to use permutation because again, in permutation, placement and order matter. Since digits can be repeated in a PIN number, the way to calculate this permutation is through the formula n to the power of r. Now I'll explain this through a little visual example. Say that there are 6 boxes in front of me, each box representing one of the numbers in Bob's 6-digit PIN number that he has to create. Now, from the formula n to the power of r, in this case, n represents the number of boxes and r represents the number of ways to fill each box. For each box, the number of ways to fill it actually is 10, since there are 10 numbers from 0 to 9. Therefore, by repeating this 6 times and multiplying each number, we can get our answer of a million different PIN numbers that Bob could potentially decide on.
Permutation with restrictions.
Jim is Bob's friend. He knows that Bob is really bad at making secure passwords and always uses the date of his birthday in all of them. Bob's birthday happens to be on June 11th. With this knowledge, Jim tries to log into Bob's account. But of course, he has to first try and guess Bob's new PIN number. Do you know how many 6-digit pins can be made if 0611 has to always be in the PIN number? How many passwords does Jim have to try before he is guaranteed entry into Bob's account? With this added condition, the number of possible PIN numbers shrinks down from 1,000,000 to only 300. Now, we can pretend that 0611 is a number on its own and reduce the number of boxes down to 3. There are only 3 places the block 0611 could fit in the PIN number, and for the other 2 boxes, there are still 10 ways to choose a number for each. This means that Jim only needs to try 300 PIN numbers before he is guaranteed access.
Circular permutation.
Bob catches Jim trying to log into his account. Jim defends himself, saying that he only wanted to reserve a table for them at a famous restaurant. Bob thinks this is a good idea and invites 3 other friends. He wishes to sit next to Lisa. How many seating arrangements would allow him to do that? In other words, how many ways can the 5 of them sit at the round table, such that Bob and Lisa are always together? If Bob and Lisa have to sit together, we can consider these 2 as one unit, along with the 3 others. So effectively, we only need to arrange 4 people in a circle. There are 4 minus 1 factorial, or 6 ways to do so. But wait, that's not all. Bob and Lisa can switch places too. Thus, the total number of arrangements becomes 6 times 2, or 12.
Permutation without repetition.
During payment, Snatch sends Bob a one-time password to verify Bob's phone number. The password starts with 3 letters followed by 3 numbers. For this one-time password, each character is said to be unique and there cannot be 2 of the same character in one password. How many different passwords could Snatch app send then? Snatch could send 11,232,000 different one-time passwords. This is how we get to that number. As you can see, for the first 3 characters, there are 26 ways to choose a letter. Since there cannot be any repetition, there would be 26 alphabets to choose from for the first character, then 25 alphabets for the second character, and then 24. This would be the same as using the formula 26p3. For the other 3 characters, it is the same concept but with 10 numbers to choose from instead. This is the same as when we use the formula 10p3. 26 times 25 times 24 times 10 times 9 times 8, you get 11,232,000, or 26p3 times 10p3.
Combination.
Finally, after placing his order, Bob received 3 gift vouchers to send to his friends. Bob has 10 close friends in his contacts who have the app too. How many ways can Bob choose 3 friends to send the vouchers to? By using the combination formula, we can determine the number of ways to choose 3 friends from 10.
Combination with a condition.
Bob decides that one of the vouchers has to go to his boyfriend Jim. With this new condition in mind, how does this change the number of ways Bob can choose friends to send the vouchers to? Since one voucher has to go to Jim, there are only 2 more vouchers to give out. Without Jim, Bob only has to choose 2 friends from the remaining 9 friends to give the vouchers to.
Combination with repetition.
After using the app for some time, Bob receives another 3 vouchers to send to his friends. He still has 10 close friends, but this time, he realizes he can send more than 1 voucher to the same person. In how many ways can Bob send 3 vouchers now? In this case, Bob can send 1 voucher to 1 friend, like before, but he can also send 2 vouchers to 1 friend, or all 3 vouchers to 1 friend. The number of ways to send 3 vouchers to 3 friends is still the same, which is 10C3 or 120 ways. But we need to add the number of ways Bob can send 2 vouchers to one friend and the remaining voucher to another friend, which is 10C1 times 9C1, or 90 ways. Then, we add the number of ways Bob can send 3 vouchers to the same friend, which is 10 ways. Therefore, the total number of ways to send 3 vouchers to 10 friends when repetition is allowed is 220 ways. We can also use the formula here to calculate combination with repetition. The answer will still be the same.
In conclusion, for events that cannot occur simultaneously, we add up the number of ways to perform each event. This is the sum rule. If the events are independent, we multiply instead. This is the multiplication rule. For the arrangement of n things in a row, R, permutation can find the number of possible arrangements. If objects can be repeated in the arrangement, then there are total arrangements. Lastly, when picking R objects from n objects, combination can tell us the number of possible choices.